Good morning. This is your Sky Spy traffic and weather reporter. It looks like it's going to be another hot day across the four-state region. Locally, we can expect to break records again today. It's 7 a.m. Across the Northwest, people are waking up and getting ready for work. Turning on the lights, taking a shower, making breakfast, brewing coffee, booting up computers, and flipping on the air conditioner. In short, they are using electricity. 8 million people in the Northwest ultimately get their power through one place, the transmission grid owned by the Bonneville Power Administration. Deep within a BPA control center, the walls are covered with a huge mural of display boards. This is a map of superhighways crisscrossing the whole Pacific Northwest. Superhighways of electricity. These patterns show more than 15,000 miles of high-voltage transmission lines, transmitting the electric energy from the many power plants across the Northwest where it is generated to where it is needed. Nearly 26 billion watts of electric power. The round-the-clock operation of the grid is controlled from the Dittmer and Monroe dispatch centers by dispatchers like Steve Holcomb. Their job is to keep the current flowing, keep generation of power in balance with demand, and protect the safety of the public and the workers who repair the high-voltage transmission lines and substations. Built by the Bonneville Power Administration and operated by the transmission business line, these highways of electricity form a grid that overlays the states of Washington, Oregon, Idaho, and Montana. At hundreds of substations on the grid, utilities and other customers interconnect with the grid to deliver electricity to consumers, homes, farms, and businesses. The whole economy on this quarter of the United States depends on the grid, rain or shine. The grid serves more than the Northwest. Major transmission lines called interties connect the region to power plants in cities from Alberta to Albuquerque. The most well-known of these is the Pacific Northwest Southwest Intertie, built in 1968. It provides a two-way street for energy from the Northwest to California. It allows producers, utilities, and marketers to transfer power from the Northwest and Canada to California in the summer, and from the Southwest to points north in the winter.
Our primary job is to maintain reliability in the power system. We're monitoring the system and the condition of the system. If it's all together, you can transfer more power. If the system starts falling apart, that's going to restrict how much power we can send. The BPA system is the 80%, I believe, is the last I heard, of the transmission in the Northwest. Our other business line has 50% of the generation in the Northwest. Now, as a transmission entity, we're here to provide transmission services for all the marketers out there who have energy to sell.
But the grid needs more than poles and wires to move electrons. It needs a communication system. Transmission's own communication system spans the four-state spread of the grid to bring the control center millions of pieces of information about the condition on transmission lines, at dams, at substations, voltage, current, switch settings, temperatures, reservoir levels, generator output. From thousands of data points, those pieces of information from the outside world are updated in the control center every 3 seconds. Transmission began replacing obsolete microwave equipment with fiber optics cable in 1994, and that proved to be just in time. With the advent of electricity deregulation in 1992, transmission has seen the use of its grid increase by more than 30%. The number of users has gone from 12 to 350. Transmission is now implementing up to 2,500 transmission schedules every day, and loads may change as much as 4,000 megawatts from 1 hour to the next.
I work on the reservation desk in scheduling, and we take reservations over OASIS, which is the Open Access Same Time Information System. And what that is, it's an internet site where Bonneville does most of its transactions. And we're one of the busiest in the Northwest, actually in North America. And at one time during this year, we actually had 5,000 requests come over for us to deal with. So we do a lot of business on that desk, and we're trying to follow FERC guidelines to be impartial and fair to everyone. So most of the information that you see out on OASIS gets posted one time, so it goes to everyone at the same time.
But sometimes there is a conflict between a customer's need to sell power and the need to maintain the system. That's where the outage team comes in. With people from customer relations, engineering, construction, dispatch, and field operations, they can plan a time to maintain the system when it is safe for workers and has the least effect on a customer's revenues. They also make sure the work is done in a way to keep reliability up and costs down. Account executives, engineers, planners, and operators also work with customers to upgrade their facilities and bring them into service. Experts in system operations make sure this change has no effect on the grid as a whole. Scheduling and the outage team share information about planned use of the system with the control center. Computers process the incoming data and report it to the dispatchers. They can then take action, most of it by remote control through computers and the communication system. At the far end of the floor sits the generation dispatcher, who can control the sources of electricity, the powerhouses at dams and thermonuclear plants. The major Columbia River dams are controlled remotely by computer. Small powerhouses require contact by telephone or transmission's own communication system. The generation dispatcher is making sure that the actual loads, second by second, are balanced by the generation he has under his control.
Hey, Mr. Selensky, what are you going to
Once maintenance work on a high-voltage line is approved, a dispatcher issues a clearance. That is, they isolate the line. Both the dispatcher and the field operator tag the line to make sure it stays isolated until the work is finished. Anything out of the ordinary starts with an alarm. The alarm comes to the dispatch center from SCADA. SCADA is short for Supervisory Control and Data Acquisition. Circuit breakers automatically trip open, removing the line from service and sending an alarm to the control center. The dispatcher using the SCADA system will reset those circuit breakers by remote control and may operate them to see if they trip again. If they do, this confirms the line is bad and will need repairs. Remedial action schemes automatically move into action. In a split second, they keep the grid stable and prevent blackouts or separation of the system into electrical islands. A helicopter has been dispatched to patrol the line that has gone dead. Transmission's extensive VHF radio system that is tied into its communications network allows dispatchers to talk directly to pilots and maintenance crews throughout the four-state region. The damage is located. In this case, it's the porcelain insulators that attach the transmission line to the tower, insulators shot to bits by vandals. Extensive safety precautions are exercised to protect repair crews from electric hazards. The damaged equipment is isolated from the system and a clearance is issued so the crew can make repairs. Power is rerouted to other lines so no consumer loses electricity. In fact, no one but the people in transmission know a repair had been made. It's been another hectic day for the dispatchers, schedulers, operators, and many others at Control Center, doing the jobs that make for a routine day for consumers. These people are the heart of this nerve center that sends electricity to far corners of the Northwest and into Canada and the southwestern United States. Hello again, this is your Sky Spy reporter with the Evening Commute Traffic and Weather Report, and it's been an uneventful day today, despite the hot weather.
Good night, sweetie. Remember, the nightlight's on for you.